All right, my name is Michael Easley. I am taking HPE 553, and I am doing my my article presentation. The name of my article is Low Load High Volume Resistance Exercise Stimulates Muscle Protein Synthesis More Than High Load Low Volume Resistance Exercise in Young Men. This was a very interesting article to me when I saw it. I'm a high school coach and PE teacher and high school coach. I coach multiple sports and very involved with our strength and conditioning program. I'm always looking for better ways to make our program better in that area, whether it be our conditioning or what we're doing in the weight room or combination of both, whatever the case may be. I'm always digging and looking for something that's a little bit different than the norm that could possibly give us an edge out on the field or in the gym or whatever sport it may be. So when I saw this article, like I said, very interesting to me, just because it kind of goes against the traditional thinking of you want to gain more muscle, you lift higher weight, lower reps, and traditionally the traditional thinking is your lower weight and higher reps are more for toning. So this article kind of challenged me to think out of the box. I really liked it. The one thing I'll say is it went way above my head. It got very detailed on some stuff that, for as far as it just went really above my head on the physical education stuff that I've had and the undergrad exercise fields that I had. So what I'm going to try to do in this presentation is not only talk about it where I can understand it, but where I can talk about it and not mess things up. So I'll do the best I can here. All right, the purpose of their research, they basically said, all right, we're going to aim to determine the effect of resistance exercise intensity, your 1 rep max, and the volume on the muscle synthesis, the anabolic signaling, and the gene expression. They were determined to see what the resistance exercise intensity, how that was going to affect all that. So they wanted to find out, are lower weights and higher rep exercises going to produce stronger muscles and, going to produce greater strength gain. So that was really the purpose of the research. Basically, the authors wanted to test a theory, like I said earlier, of lower weight, higher reps, and to see if they could stimulate more muscle protein synthesis than your higher weight, low reps, which is what your traditional weight gain theory is. If you wanted to gain more muscle mass, then you do the higher weight, low reps. So they're kind of going against the norm here. They tested a group of men. They used one specific exercise, but they tracked the different aspects of protein synthesis, to try to get a better understanding of what was going on. And they used different time increments to check results, to just basically see whether their theory was right or not. They referenced, there was probably 50 articles referenced throughout this review, and just a couple of them that I chose to pick out that kind of was important to the article. One was a article from 2009 titled Age-related differences in dose response of muscle protein synthesis to resistance exercise in young and old men. They basically used this to show the protein synthesis or to show how it was affected by resistance exercise and the decreased sensibility and basically the lack of capacity for increases in older men. So basically they're studying how basically the age difference in saying they're older. The older you get, I guess the smaller capacity you have for weight gain. The next article was from 2006. It was titled Muscle Size and Strength or Increase Following Walk Training with Restricted Venous Flow from the Leg Muscle. It was basically, they took this article, I guess referenced this article, to basically show the metabolic adaptation in skeletal muscle that is similar to the metabolic response of the muscle. Excuse me. The third article is from 1995, and it was about, again, about protein synthesis and just using it in different ways, and when it comes to amino acids and stuff. And this was basically, they were just trying to use this to support and show that blood reflects that of muscle protein, is all it was. So their hypothesis, the authors basically theorized that there increases in muscle protein synthesis um, that doesn't necessarily require the heavy loads as a prerequisite. Um, your muscle gain or your hypertrophy. I always say that word wrong, but the hypertrophy, um, the muscle gain, that doesn't have to. It doesn't always require heavy loads to do that. Um, Basically, the protein synthesis was already stimulated at 60% of a 1 rep max, so you don't necessarily need the gain, the weight gain to get the muscle increase. Um, they did this study with 15 men. They they found them through, they were all volunteers, and they found them through a questionnaire, and they were all volunteers. All participants was 21 years of age or older, and all participants had to be recreationally active. Now, they required a 6 months in advance. They had to be active 3 days a week in some kind of form of exercise. Essentially, they did not want somebody that they didn't want a couch potato to come in that never works out and never has any kind of exercise involved in their life. They did not want that because it would skew the stats. They wanted people that were at least recreational active. That basically worked out 3 or 4 times a week. Not necessarily a workout. It could be, or people that ran. It could be people that worked out in the weight room. It could be people that went and played, pick up tennis or pick up basketball, stuff like that. Just something to keep you active. They were, like I said earlier, they were all the participants were volunteers. They were informed of the purpose of the study and all the experimental procedures that were involved in that. They were warned of all the risk ahead of time, so they knew the risk going in before they even gave their written consent to perform this study. They were all deemed healthy based on their response to just a routine medical screening. They did that through questionnaire also. They even got the study approved by the local Health Sciences Research Ethics Board of McMaster University. They formed the standards for use of human subjects in research as outlined in the Declaration of Helsinki. All these subjects were instructed to eat no later than 2200 hours, which is 10 o'clock p.m. on the day preceding the trial. All the subjects recorded their dietary intake for 3 days before resting muscle protein synthesis measurement. They did that measurement on all of them. This intake was replicated before the exercise muscle protein synthesis measurement. On the morning of the trial of the study, the exercise, the 2 hours before arrival, all subjects consumed a liquid meal that provided 15% of the estimated caloric need for that day. So they were very strict, and they wanted to make sure they could monitor. They didn't want different foods or anything that they took in to skew any stats that they had. So what the subjects did, they performed 4 sets of unilateral leg extensions at different loads. So they did the 90% of max until failure. They did the 30% max until failure. They also did the 30% max at a basically trying to reach a point, but that was not the focus, and you'll see it in the charts, but that was not the focus of this study. The focus was the 90% and the 30% max until failure lifts. They measured the rate of protein synthesis at rest and at 4 hours and at 24 hours after the exercise. Basically, like I said, the protein synthesis was measured at 4 hours post-exercise and 24 hours post-exercise. So once they started looking at all their numbers and their data, they essentially saw where there was a significant increase after 24 hours with both the 90% reps and the 30% reps, but the 30% reps were higher. Again, both of those are until fail. So then there's 3 charts here. The next 3 slides are just charts, or just protein synthesis charts. As you can see, the clear one is the 90% of max to fail. The ones with lines is the 30% max to fail, and those are the really focal points of the article here. As you can see, the 4 hour, if you look at the first chart there, after 4 hours, you can see that the 90% fail is higher, but the 30% to fail isn't too far behind it. Then you go 20 hours later into 24 hours post-exercise, and the 30% to fail has really jumped up ahead of the 90% fail. So that was a really big, to me, that's a really big stat as a educator and as a strength and conditioning person. Seeing the impact that has over 24 hours right there just really opens your eyes. This is just another chart here, more of the same stuff. You see at the 4 hours post-exercise right here, the 30% max is actually a little bit higher than the 90% max, and then after 24 hours, the 30% max gets even bigger over the 90% max. Same thing. This is just another chart. These are broken down into different. The first one was mixed, and then the two kinds of protein synthesis, they just kind of broke them down. But the value, the end result was what they were looking for, which again, 4 hours post exercise. Both of them have gains, but the 90% max is a little bit higher. But then again, you go 20 hours later to 24 hours post exercise, and you're looking at a pretty good, significant lead for the 30% max to failure. So that's staggering numbers to me on every one of those charts. At 24 hours later, you're looking at 30% of your max doing that until fail is making larger gains in muscle mass or muscle gain than 90% max, which is the traditional theory there. So just going back over them, you can see in all 3 charts that 30% max had a higher rate of protein synthesis after 24 hours, which is, the 90% max was still productive, but the charts and the data tells you that 30% just had better results overall. As you can see, the analysis of the data, protein synthesis was elevated above the rest in all conditions at 4 hours post-exercise with a 90% max. It was elevated above the rest in all conditions at the 24-hour post-exercise max with the 30. The response was sustained above the rest after 24 hours with the 30% max to fail than the 30% of the weight max condition, which was, again, that one was not the focal point of this study. So, just looking at the data, it clearly showed that the greatest muscle gain and the greatest muscle protein synthesis came 24 hours after subjects repped 30% of their weight max until fail. And again, that's just staggering. That's a staggering stat for somebody that's been around weights and strength conditioning all their lives. And basically, the best way to gain muscle gain is to use lower weight and lift to fail. In conclusion, it's just what I said before. All our results are saying that low load, high volume resistance exercise is more effective in producing acute muscle growth than high load, low volume work match resistance exercise modes, which is against what we've always known. And the higher volume resistance has a effect, with signaling molecules and muscle protein synthesis. And after 16 weeks of that, you should see significant increases. In closing, the authors basically said that they need, they did say a study training in which distinctly different exercise loads, the 90 to fail and the 30 to fail, are utilized fully is definitely warranted, and they confirm what they have discovered with this test. Like I said, with this, for being around lifting weights and strength and conditioning all my life, this was a very eye-opening article, and I think now it's really going to change the way that I look at strength and conditioning.